so we're going to discover something kind of interesting with inequalities, okay? So let's pretend I have, now we are going to, oh, I'm going to use my negative cards. Totally forgot to get out my negative cards. Remember my positive and negative cards?
Yeah.
We're going to use those, and we're going to see what happens when we do math on our positive and negative cards, okay? So I'm going to draw 2 cards, and we're going to do an operation on both sides. Now, do you guys agree? Like, let's say I have 5 equals 5. Like, if I add 2 to both sides, is it still equal? If I subtract 7 from both sides, is it still equal?
Yes.
If I do anything to one side, it's going to be the same. Now, with greater than and equal, greater than and less than signs, let's say I have 5 is greater than 3, or 3 is less than 5, we are going to find out if we perform different operations, if it's still going to be true. We know with an equal sign, I can do whatever I want, as long as I do it to both sides, and it's still going to be equal. But is that true with greater than and less than signs? We're going to find out. We're going to find out. So I'm going to draw 2 cards. Some of these will be, remember if... Okay, so remember, if it is a black card, is it positive or negative? And if it is a red card, it is negative. Okay, so my first card is, negative 10. So in your column here, we all have columns. You're going to write a negative 10 for card 1. And we're just going to be doing different operations. So we have negative 10 and we have, positive 9. Which one is bigger?
I wonder.
Negative 10 by far.
Would you rather have $9 or negative $10?
I don't like
be in
it.
debt.
I don't want to be a debt either. This, if the alligator eats this one, he's going to starve to death. Okay, so 9 is bigger. Okay, so now,
But I want to be in debt.
I know you don't. Okay, we're going to perform an operation. We are going to add negative 3 to both sides. Okay, so that's the same as subtracting 3. So what's negative 10 minus 3?
Negative 13.
Negative 13. And what's 9 minus 3?
6.
Is negative 13 still less than negative 6?
Yes.
So, does adding a negative number change my inequality?
No.
No. Adding a negative number, they're different numbers, but the one on the left is still less than the one on the right. Okay.
Wait, so what do we write for the other box?
So our new inequality is negative 13 minus 6.
I know the one.
Oh, and the inequality symbol, it was preserved. It didn't change, still pointing in the same direction. It didn't flip. Some of these, we might do an operation that might make it's not true, so we have to flip the inequality to make it true. Let's see.
October sky.
That's a movie.
I won't know this.
My science class is watching a movie. Okay, first card is negative 5. Second card is 3. So that one's bigger. Now we're going to subtract 2. Okay, so minus 2. What do you guys predict? We subtracted 3 up here, and the less than sign didn't change. Do you think it's going to be the same?
Yeah.
Let's find out. What's negative 5 minus 2?
Negative 7.
Negative 7. What's 3 minus 2?
1.
Is negative, oh, wait, I wrote negative 3, and I do not know why. Is negative 7 still less than 1?
Yeah.
Yeah, it is. So, was it preserved?
Yeah.
Totally was preserved. Okay, let's look at this one. are going to have 4. Oh, we finally got a positive 1 for the first number. And, oh, a positive 7. Okay, which one's bigger? So far, the second number has been bigger every single time. Like,
This one's gonna change.
well, let's see. So let's multiply by -1 and multiply by -1. What's 4 times -1?
-4.
-4. What is 7 times -1? Negative. And it's exactly as Emma predicted. Yes, Clara.
Do we write all of this down?
Yeah, you've got 4 columns. So your card 1 goes in the first column. No, you have 5 columns. Your inequality sign goes in the middle column. Card 2 goes in that column. The new inequality, which would be like -13.
Like all of those that you just wrote down.
We are just going down your column. So if you don't, it's a points for every single one of those. So yes, you're gonna write down every single one. So we're just going down the column. So on this one, we're on the first multiply by -1. So Emma predicted that it would switch. Is -4 less than -7?
No.
No. -4 is bigger than -7. So we multiplied by a negative and our sign switched. Should we do it again and see what happens?
Yeah.
All right. Who just said they're confused? Well, we multiplied by a negative and we had to flip that sign. Let's see if it happens again. We're going to multiply by a -1 again. So the first card is 5, positive 5 again. Second card is, -8. Finally, we have one where the first one's bigger.
It's gonna change.
Okay, we're going to multiply them by -1. So times by -1 times by, what's 5 times -1? -5. What's -8 times -1? Positive 8. Oh, and the sign reverses. So both times we multiplied by a negative. The sign, maybe it's the multiplication. So on the next one, we're going to be multiplying by 2. Yeah.
Could we get our own cards for this one? Last one?
There's more on the back.
Yay, I like these. They're fun.
If you want, you guys could do just the last 3 on your own.
Yeah.
Or we could do them together.
Just do them.
Alright, let's draw a card. -7. Oh, I need a new color. I don't know.
Me too.
What if they're equal? Then we have to get a different. No, we have to get a different one. Because we know nothing changes with equals, but we're exploring what changes with greater than less than inequalities. And +6, most certainly not equal, and a +6 is bigger. Okay, so we're going to multiply by 2. So this will be a good test to see if multiplication changes the sign, or if it's multiplication by a negative that changes. So we know multiplication by a negative changes the sign, but does multiplication in general. So we're going to multiply by 2. So what's -7 times 2? -14. And what? I messed that up. What's +6 times 2?
12.
12.
Why does that take us so long?
Is 12 bigger than -14? Yes, quite much. In fact, this one is bigger by 13, and this one is now bigger by 22.
What? Oh.
No, 26. It doubled. So, was it preserved?
Yeah.
So does multiplication switch the sign? No, but what does?
Negatives.
Multiplication by a negative. Let's see it. Let's test this theory. Test this theory. So, now we're going to do some division.
Yay.
Well, that's going to be fun. I need another color.
3.
I'm running out of colors. Although I think it's kind of impressive actually that I have this many colors. 3. Oh, guys, did you hear Braden say 3?
I did.
And then look what card I just drew.
No, you drew negative.
I did draw, but it's a flavor of 3. It's the negative flavor of 3. It's strawberry 3 instead of licorice 3. Okay, what do we predict? 5. Negative 5, actually. Which one's bigger, negative 3 or negative 5? And I'm kind of sad because we're dividing by 2 and neither of these is an even number, but we can handle this. What is negative 3 divided by 2?
Probably
Negative 1.5.
Negative 1.5. What's negative 5 divided by 2?
Negative 2.5.
Which one's bigger?
Negative 1.5.
So when we divided by 2, did the inequality change? It was preserved. All right, we're going to multiply by negative 3. Now, what do we predict? We're going to multiply by negative 3. Are they going to change? You think it's going to change?
Yeah.
5.
Guys, I have enough colors to pull this off. I am feeling special. Okay.
I said 5.
That's negative 5.
Yeah, I know, but he got the number right.
But it's shut up.
Just didn't get the flavor.
Just do 7.
2. Well, 5 plus 2 is 7. But this is still 2. And then 2 is greater than negative 5. Oh my gosh, are you pure? Are you like, really, can we not? I mean, seriously. All right, we're going to multiply by negative 3. So what's our prediction? What's our prediction, guys?
Change.
Think it's going to change?
Why did you do 2 negatives? That's
Can I please get Evan Van Leuven to come to the office? Evan Van Leuven, come to the office.
What do you mean, why did I do 2 negatives?
The first one, it is negative 5 minus 3x. What is that?
This is times negative 3. I just made the dot kind of big. Now it's even bigger. It's bigger than it's ever been, and now it's even bigger. Okay, so what's negative 5 times negative 3?
Negative 15.
Negative times
15,
negative is a
15,
positive,
15.
so it's positive 15. Negative 2. You already, so like, you didn't even let me finish, and you told me it's negative 6. Oh, we're right, it flipped.
Reverse it.
It reversed it. Oh, wait, we're going to be dividing. Dividing by negative 2. What do we predict is going to happen when we divide by? We divided by regular 2 right here, and nothing happened. But if we divide by negative 2, what do we predict, guys?
It's gonna change.
Think it's going to change?
Yay!
Okay, Brandon thinks it's going to be a 7, and it is a negative 4. Down here. So negative 4, and then we have
The next
negative
one's
10.
gonna.
Oh, and they're even numbers, so the division will be a little nicer. Which one's bigger? Negative 4 or negative 10? Okay, so we're going to divide by negative 2. Divide by negative 2. What's negative 4 divided by negative 2? Just regular 2, right? Positive 2.
And then 5.
And then 5. Which one's bigger, 2 or 5? So
Minus 3 equals 2, so 2 is bigger.
they flipped.
Can I eat Brayden?
No, you can't eat Brayden. And Brayden, stop turning around and looking at Ty. 'Cause you're not allowed to eat people. That's like against the law.
Unless they're already dead. Wait, really?
No. Even if they're already dead, you're still not allowed to eat them unless you're going to starve to death, which you're not. I have animal crackers. I have you covered. Not right now. Actually, I need to go get one. I've had a box of animal crackers in my car all week long that I can't remember to bring into the school. All right, let's move on, guys. Yeah, sharpen your pencil quite quickly. I do want to show you. Now we've done a little bit of this with like the ISAT review, but I do want to show you how to graph inequalities on a number line. So if you look at, we're going to do number 1 together. Okay? Number 1A. I am not doing A, B, C, and D, but we're going to do 1A together, and this board doesn't want to erase. Okay. So we have 5 plus A is less than 7. Okay? I care about A. What does A look like, right? So how do I do this? How do I get this A alone? What do we do?
-5.
I thought I heard the bad by 5. So we subtract 5. If I subtract 5, is that going to change the direction of my inequality sign?
No.
No. What if I multiplied by -5?
Yeah.
Then it does. Okay. So I end up with A is less than 2. I'm going to graph this on a number line. I can graph this. What?
Right side.
It won't. If we multiply by -5, it will. If we subtract 5, it won't. We just learned this. So I'm gonna make myself a little number line here. There's 0, 1, 2, 3. Does not need to be big because I only need to get up to 2, right? 1, -2, -3. So this is how you graph these. Does it equal 2?
No, it's A is bigger.
A is less than 2.
Less than 2.
So I'm going to make a little circle at 2 to say that it does not equal 2. If it did equal 2, I would fill in my circle. But it doesn't. So I don't.
So then you do a 1 for the dog.
Okay, so there's my thing. And then it's all of the numbers that are less than 2. So I'm going to have an arrow that goes that way and says it's everything that's less than 2. And that's how I graph that. What if it was all the numbers that were bigger than 2?
Then it will be going to the right.
Then it would be going to the right. And if it's equal to 2, then we fill it in. We don't have any on your assignment that are equal though. So they're all going to be open circles. Okay, that's how you graph them. Graphing them is really pretty straightforward. So we're going to do some problems with these.
This sounds fun.
The annual, today's a good day. I like this math that we do today. The annual county carnival is being held this summer and will last for 6 days. Sounds about right, except it's the state fair and it lasts for 9 days, but whatever.
It does? I thought it was only like 4.
The state fair is 9 days.
Oh.
Friday, Saturday, and then a whole week. Trust me, all the teachers know exactly how long this thing lasts because it messes up school so bad. The fair messes up school really bad.
Which
Okay.
is good.
Yeah,
Good in a bad way. Good in a bad way.
Yeah.
I remember so many people miss school just for the fair.
Nobody does homework during the fair.
The fair was during July.
Fair is in September. Okay, Super Y teaches us how to read, and this is math class. So let's do this.
No.
Why though?
You can't be science.
We are solving.
Whoa, I own the biggest and newest roller coaster.
Can we watch
You guys ready to do this?
Yes.
equals 2?
Okay. Okay, come on.
We ready?
Yeah.
Okay. Okay. You are the owner of the biggest and newest roller coaster called the Gentle Giant. Go you. The roller coaster costs $6 to ride. The operator of the ride must pay $200 per day for the ride rental and $65 per day for a safety inspection. If you want to make a profit of at least $1,000 each day, what is the minimum number of people that must ride the roller coaster? Whoa! Hello! There's a lot there. Okay, so our profit. What is our profit going to be?
1,000 each day.
Well,
1,000
more than 1,000, or at least 1,000. What does at least mean?
like
Could
be or that or more.
At or more. So how do I say that in math language? Greater than or equal to $1,000. Okay, so whatever our profit is over here needs to be greater than or equal to $1,000. Now, how do we make money?
The people riding.
$6 a ride. So we're gonna have $6 times the number of rides, right? Or the number of people.
Could we just put 6x?
You can put 6x, you can put 6r, you can put 6p, or you can use whatever letter you want. I chose R for rides, and it might need to be P for people. I'm gonna do P for people because it says how many people. Okay. So the operator of the ride must pay $200 per day. So what does that look like in our equation when we're paying $200? Minus 200. So we're gonna pay $200. Okay. And $65 per day for a safety inspection. So what does that look like on here? Minus 65.
That's a lot.
So we can add those together.
So this is when it says write our inequality. This is letter A. We wrote our inequality. Solve the inequality. So Coulter, you were telling me how to solve it. What do we hide? What?
We add 200 and negative 200 and negative 65.
We combine some like terms. We end up with 6p minus 265 is greater than or equal to 1,000. Now what am I going to do? How do I solve this?
Oh, wow.
Size up big numbers. Can I do big numbers?
No.
I can do big numbers.
No.
How do I do this, guys?
Wait.
We're going to add 265 because we need to get this variable alone. So plus 265, boom, that goes away. Plus 265. So we end up with 6p is greater than or equal to $1,265.
What?
Now what?
We divide 1,265 by
Divide
6.
both of them by 6. Oh, this isn't going to be pretty.
Can I just
So
but you
p
can make it pretty.
needs to be greater than or equal to 1. 210 point something. Can you have point something people?
No.
No, so in order to have a profit, P needs to be greater than or equal to 200. We're going to round up.
11.
Because if he has 210 people, that's enough. Not enough, but if we have 211 people, that is enough. So P is greater than or equal to 211.
Yeah.
So you've got to have 211 people on this ride every day if you want to make $1,000 every day.
$1,001 profit each day if you get
1,001.
Can I make $1,000?
If you have a ride and you charge people money like this, sure.
Put a colorful cardboard box in your front lawn and ask homeless people to ride in it.
So that might not be the most effective way.
Kidnapping.
Homeless people are usually homeless for a reason and they don't have money. Okay. Example 2.
You can sell your box.
But these are all just examples. I'm going to let you guys do example 2 yourself. This is a pretty short assignment. I'm not going to do example 2 for you because that's the whole assignment.
What?
Mhm.
No,
So-
then there's 2 and then there's 3.
But you guys need to do some of this on your own. So I'm going to let you guys do the others. Oh, you can do it. You guys are smarty pants.
No, we can't.